Let's find all relative extrema of this function. We got f of x is equal to x squared minus 25 to the third power. Well, first thing we need to do is find our derivative. So f prime. Now this is the chain rule, specifically a general power rule. We got parentheses to a power. Take your power, put it out in front. What's inside the parentheses remains as is. Lower your power by 1, and then you multiply it times the derivative of what's inside the parentheses. So that gives us 3 times x squared minus 25 to the second power times the derivative of x squared minus 25 is 2x. Which gives us 3 times 2 is 6x times x squared minus 25 to the second power. Now the next step is we want to set that equal to 0 and solve it. So we got 6x times x squared minus 25 squared is equal to 0. Now, zero factor property says you get 0 on one side, you factor the other side, you can set each factor equal to 0. So I'm going to set 6x equal to 0, and I'll set x squared minus 25 to the second power equal to 0. Now here we'll divide both sides by 6. And 0 divided by 6 gives us 0. Now here, if you got parentheses to a power equal to 0, you can drop the power. So this just becomes x squared minus 25 equal to 0. Now take the negative 25 to the right side, it becomes a positive 25. Square root property. We drop our squared, and we put a plus or minus square root around the other side. Use the square root property whenever you have something squared equal something else. Well, square root of 25 is 5, so we get 0, negative 5, and 5. So we got x is equal to negative 5, x is equal to 0, and x is equal to positive 5. We build our table of intervals. Clear over here is negative infinity. Clear over here is positive infinity. We want to choose test cases. I want to choose something between negative infinity and negative 5, like negative 6. We want to choose something between negative 5 and 0, like negative 1. We want to choose something between 0 and 5, like 1. And choose something between 5 and infinity, like 6. Now we want to plug those into our derivative and see what it gives us. Our derivative is right here. So let's go plug that in the calculator. Press my y equals, clear, and we got 6x, beginning parentheses, x squared minus 25, closing parentheses, squared. Now I want to make sure my calculator is set up right for the table. So if I do second window, your table set up under independent should say ask. If it doesn't say ask, down arrow to that line, right arrow, and press enter on the ask. Then do your second graph, go in your table mode, and I got a few here, so I'll clean them out. Press delete over and over. And we want negative 6, enter, negative 1, enter, 1, enter. Just putting in all my my test cases, then 6. Enter. Okay. Negative 6 gives us a negative number. Negative 1 gives us a negative number, so both of these are decreasing. 1 and 6 both give us positive numbers, so these are increasing. Now our extrema occurs where it changes from increasing, decreasing, or vice versa. Well, here it's decreasing and changes to increasing, so this is going to be a min. So it's going to be 0. There we go. Now we want to plug 0 back into our original function and see what our y value is. So I'm going to use calculator for this. I'll be lazy. I'll press y equals, clear, and I got beginning parentheses, x squared, minus 25, closing parentheses, caret 3, third power. Okay, now I'm going to do second graph, go in table. Now press delete over and over, clean those out. And we'll put in 0 in, and then press enter. And that gives us negative 15,625. And that would be our answer. Min is 0, negative 15,625.